This conference will now be recorded.
Okay, so today what we'll be discussing is like AWS itself. We'll start with AWS Cloud first, and we'll go next with the other topics that we have. So, and AWS also, I'll be coming. I'll first give you some kind of basic services in the AWS. Again, I'll switch to the Linux operating system, and again I'll be coming back to the AWS. So that is the whole idea of AWS and all that. So today I'll tell you about cloud and why the cloud is useful, why we need to move to the cloud. And instead of just giving you an introduction of some services in the AWS, so what do is I'll take a real-time example, like let's build some Facebook or Instagram kind of application. And what if there is no cloud? How do you build it in a normal data center? How do you architect it? And when you have a cloud, how you can replace the different pieces of components of the architecture with the cloud technologies. So that will give you a more clarity than me telling you what is this service does, what does that service does. You can't connect in a real time. So first I'll give you an emphasis of complete AWS services, why we need to utilize all the AWS services, and then I'll come to the AWS part, and I'll show you creating an AWS account today. And the first topic would be identity and access management, like how can you create more users to access the AWS account, and what kind of permissions that you can give, how can you divide the groups, exactly, like more about identity and access. And later we'll move to the creating virtual missions in the AWS. So that is the first thing that we'll see. So before that, I want to give you a clarity on cloud, like what exactly is a cloud? Like many people have it, like they may be having a doubt, like is cloud everything, or what exactly is a cloud? How can we define the cloud? What is a cloud computing and all this? So the cloud computing, you can think of the cloud computing is something where you just create some kind of computing resources for your use case. So if you generally take the definition from the like Wikipedia, it's a kind of utility service where you can manage your technology. You can take something on demand. For example, you want to start a business, you want a server. So you can just go to a cloud, create a server, and run your application. So as simple as that. One advantage with the cloud computing mainly is the kind of way that you pay the billing for the cloud. So you can think of a kind of electricity services. So in your house, you run the appliances, and only for the appliances that you run, a bill will be generated. For example, if you're not using one appliance for, like, let's suppose in the winters we don't use AC, so we turn it off. So it doesn't generate any bill for you, even though you have an appliance. So it will only generate a bill for you when you use it. So exactly the same thing goes in the cloud computing. So when you require something, some kind of utility service, you try to just create it and you use it, and the billing will be charged for per minute or per hour, and based on that you'll pay. And if you don't want it, you can just terminate it or delete it. So in why this is very important is, like, let's suppose if you're building something, like you're building a website, a normal website, or a mobile app or something. You don't know till you go to the customer. You don't know how your application or your website or your any kind of e-commerce website that you're maintaining, you're building, that doesn't really, you don't know, like till you go to the customer, you don't know how the market will be, how you can sustain in the business and all that. In normal sense, what you need to do is you need to go to a data center. You need to purchase a server is a kind of like you have a different kind of missions which are called servers, like similar to the laptop but with a higher compute and memory and all that. So you need to purchase that, and after that maybe someone may start in the office or in garage or anywhere. Maybe you need to put in your office, you need to rent a space and you put the servers in there. And there should be some person who should install the operating system, who should install all the things for you, who should manage the server. If power goes down, if your application goes down, so it's a bad thing. So you need to see that the power sources and also the internet sources, the backup, everything is properly maintained, which is a huge expensive. So like once you're growing in the business, it will be a very huge expensive if you want to maintain the servers on your own. So there would be a lot of things that you need to manage manually. You need to hire people, and the people should be 24/7 monitoring your missions. any business will be very difficult if you're having this kind of setup, which is not a cloud. So the cloud is a place where you rent the things. You go there, you purchase some virtual, like any virtual machines or servers or whatever you want, and you run certain things. It is only a kind of rent something. If you don't want, you delete and terminate it. And you have all the security, everything compliances are there so that your data will not be exposed. And all, like you can literally, there are public clouds and there are private clouds. You have many things. Like Amazon is a public cloud where you go and purchase it and where you run certain things. And now these are the main advantages of the cloud computing. You need not have any capital expenditure. So for example, in previous case where we need to start a business, you need to purchase the servers. You need to put a lot of money in purchasing the physical servers. And let's suppose if your business doesn't go well, you need to literally scrap them all. Like you need to sell it off. And this kind of expenditure is very huge. So in cloud, there is nothing like you need not pay anything. You just pick it up, you run something, and if it doesn't work, you can just terminate in one click, and you only pay for what you have taken, nothing more than that. It's a kind of rent. So like you rent an apartment, you stay there and you just go off, and with all the amenities and all the things also. So that is how the cloud works. And the main thing is pay as you go. You just pay. For example, let's suppose I want a big data kind of thing to my product. I'm just doing a POC. I just run some big data clusters. I do something, and if that doesn't work, I'll just terminate that off. I only pay for something which where I used it. So this is a kind of advantage we have in the cloud computing. And it's truly elastic capacity. You can scale up and scale down. So what is mean by scale up and scale down? Like you can add more resources, you can delete the resources, it's all up to you. So that is called an elastic capacity. So let's suppose if Amazon is running some prime days during which they have the discounted sales and a lot of people try to access their application. So during that time, their application is something that should scale up, which can handle any number of users, any number of people can come there and they can purchase it. Or there is suddenly one kind of offer that is going on, which is like flat 70% off on one particular mobile, and a lot of people try to purchase it. Then you need to have your website in a capacity to handle any amount of traffic. So putting that in the cloud, it's very easy. We'll discuss these kind of concepts in the course. What is scale up, scale down, but that is a real time scenario where it comes into the place. And it improves time to market. Like and like once you have your product ready very fastly, like you can just go to the market, like you can directly sit on the marketing, and you can go into the business instead of putting much of the time in maintaining the physical servers and all that. And you can focus on what really matters than the infrastructure related things and all that. So so I'll show you how easy it is to create anything in the cloud and how you can use it. So that is a main intention of going into the cloud rather than sitting in a normal physical servers and a data centers. It will be very expensive job. Okay, now what we'll do is firstly this is about AWS computing. So like AWS cloud is nothing but it is a combination of different data centers. Like they have their data centers in many regions around the world. Like they have around 25 regions. Like every region is a kind of city. So like it in India it's in Mumbai, and in US you have 4 to 5 regions. In Australia you have one region. So every region will have something called availability zones. I'll come to this slide later when I'm telling about AWS and how what kind of infrastructure AWS has, why we need to go to the AWS. I just want to concentrate on these things. Okay, so AWS has many kind of services. So if you see, there is a compute service where you can create virtual machines that is called EC2, and you have load balancers, you have a container based service that is ECS, you have EMR and Kinesis kind of things which is used for big data and streaming, like data streaming and all that. So if I go on telling like this for you, for example, what is this service, what it does, it's a kind of, you will get unconnected and you can't remember everything. So what we'll do is firstly we can divide the services into these things like compute and analytics or storage or database. For example, the database, you have RDS where you can create the MySQL servers or PostgreSQL. You have a NoSQL databases or a data warehousing and all this. Along with that, you have a storage kind of services. Let's suppose you want to host a YouTube kind of service. Then S3 is a external storage. It is a unlimited storage that you get. You can put all your videos and in different formats, and when you open a video from YouTube, this is where all the videos get stored. So that is how a different services will be used here. So what we'll do is we'll go and try to develop one simple architecture, and we'll come back again to these services in understanding how you can replace all these different components in the architecture. So that let's try to build some Facebook or Instagram kind of thing. So you'll understand what kind of components will be involved in that, and how the cloud will help to like replace those components in normal data center to better things. So what exactly you need when you are building anything like Facebook or Instagram or anything? The first thing that you need is some kind of web server. So I'll just write it down here. So you can stop me at any point if you are not able to follow. Like we can just discuss if you have any other doubts or anything. It's not something like we should only discuss the Q&A at the end of the complete class. It's like you can stop me at any point and we can just discuss with the architectures that you have, or like if you're not able to understand anything, I'll try to give you more examples while I'm telling. So firstly, you need to have a web server. So what is a web server? So normally when you go to the browser and when you type http google.com or something, that will be a client which needs to connect to something to get the response. Like there should be something where your HTML pages should be there, a HTTP server should be there, which will give you the response with the complete web page. That is called a web server. So generally web servers will give a static content. So it could be a normal HTML, and it can also be added, like it can be made into a dynamic by adding some kind of plugins for PHP or anything. So example of a web server would be Apache. So for example, if this laptop is there, if I just install the Apache on this laptop, and if I put any HTML pages, and if I add a domain name so that it should connect to my laptop and serve it, then my laptop becomes a web server. That's as simple as that. If I install MySQL software in my laptop, and if I create databases, and so that some application can connect to this and can create the tables and all that, then this becomes a MySQL server. It became a DB server. So you can think of like this. So in this, you have a different servers which are intended. The purpose of it too is to serve something. And you have application server where maybe you have a business logic where that needs to connect to a DB, and let's suppose it should store some information in the DB, fetch from that, and run some queries on the DB. All that business logic can be done using an application server. Like regular example should be the Tomcat, WebLogic. All these things comes under this category. So the first thing that we need is a web server which can serve the content, the static content. If you want to build a Instagram or something, the first thing you need to have is a web server which will do the things. So let's go like this. So you have an IP. So let's not introduce the DNS now. Everyone knows you need a domain name to connect something. You can't remember the IP. IP is an internet protocol. It's like you can't remember the phone number, right? You can only remember the people's name, and you go to the contacts and you try to search with the name instead of the phone number. So in the same way, everyone can't remember the IP. So let's just put it like this. Later we'll change it to the DNS part. But now my concentration is on this one. So now you have a private network. It is a network which is like allocated privately to building our website, so that you can do in a cloud or normal or anywhere. So anything which is in the private cannot be exposed to the outside. You can't connect from the outside. That is the whole idea of the private network. So now you have a web server. Let's say you have an Apache web server or something, which where you have a disk, and this is a virtual machine where you're running your facebook.com. Okay, you just start with basic HTML and CSS and all this stuff on JavaScript. Now you need to increase the business logic, right? So you need business logic, and you need something which does the application server part instead of just serving the static content. You need something which can do the dynamic things, like you can post a reel and someone can like it, and you can again edit the things, and all these kind of things are dynamic, which you do on the any FB dot like Facebook or Instagram. So you need something more logic here, and you want to store the details. So like all your login details, or like the details of the metadata of the post that you have done, the time of it, and when you have updated, these kind of things will be there, right? So you need to have a database. So this is a very simple architecture. Like this is what we do any website will have this. So you have a web server which will serve the content, and you have a app server which serves the dynamic things, and you have a database where you store the things and you run the queries. Let's suppose you want to fetch something like all the friends of a friends. It needs to run some graph db or something, or let's suppose any normal query it should do, and it should give you the result. So that is the whole idea here. So this is how it looks. Now this looks okay, but the problem is, like, what if I want to cater more users? Like Instagram has millions and billions of users, and Facebook has many users, right? So this simple architecture doesn't really suit to really go into the business. You need more. You need to have an architecture the way that you can scale it. You can add more things. So then what you can do is you can add more web servers. Like scaling is nothing but you add more capacity. So you add more things to that. So you are trying to add more web servers here. You are trying to add more app servers here. Again, they're connected back to the DB, and things are working fine. But now here, there is one problem. So when you have multiple web servers, there should be something which can divide the load. Like for example, you go to a restaurant, and in the back end in the kitchen, there would be 4 to 5 cooks, but there should be someone who should tell the cook what is the things that you need, like what is the food that you want. So there would be some middleman. You can think like a person, a waiter comes to you, takes an order, and he is the one who will tell in the back end cooks, like, you cook this for this person, you cook this for this person. So that is what a component called load balancer. So you have a load balancer. So now all the people will be first, all the connections and the request first comes to the load balancer. Then it will divide into the different things. Then it will divide into one, it will send into this VM, this can send into this VM, and the request can go back to till the DB, and you can post the things, you can put the reels and all these things, you can do it. And now I want this one to be built in the data center. So what I need to do? So firstly, I need to look what exactly how the load balancer works. And I need to go and install some software which supports the load balancer. So there may be something called HA proxy. So if I just go to this particular software, so this is a famous software which is used for the load balancer. So I need to install this. So what I need to do here, I need to have around 6 missions. Okay, if you take this one. So in this,
Excuse me, sir.
yeah, please.
Sir, can you give few more examples for web server and app server?
Examples, you mean like software is that deal it, or like what is web server, what is app server, what it does?
Yes, 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 yeah. What is web server, and can you give more examples for that so that we can
Yeah.
understand?
So yeah. So when you do a normal google.com, like this is a kind of HTTP request that it has. It's a hypertext transfer protocol, which is like, which you send a request. Now this browser is called a client, what I'm doing. So this should go the client will take this request, and it should hit something like the server here would be google.com. Okay, Google has a server which has, it is a normal mission which has an HTML pages, so which has a content what you see here. So this is like, if you want to make like this server is created in form, like you take a normal machine, like it could be a normal like you can think of a CPU or a rack CPU or something. So where you install some operating system and one software which will be the web server. So this could be like Apache, as I told you. So this is one of the very famous HTTP server you call, so which serves the content of the HTTP. So all this World Wide Web works on HTTP itself. Now this is one of the famous example. Like if I this is a software which turns, like when you install this one on any machine, like my laptop, if I just take a .exe file, how you install a normal Firefox or a Chrome. If I install this one, then it becomes an Apache web server. Then I just need to go to some place, like I can put all the files in C drive. Somewhere I can create some HTML folder, and if I put all the files in this particular folder, then this becomes a web server. Then what I need to do is I need to first register google.com. Okay, something like this. You can just see this as an example. This should be pointed to my IP of this laptop. So IP is nothing but internet protocol. This is the way we identify any mission in the network. For example, these days everything comes with an a network interface card to be identified. For example, your TV is a smart TV. It is connected to the router. It will have an IP. And if your AC is an if AC will have an IP because it is connected to the Wi-Fi, and you can just turn on using your mobile or any app. So everything should have an IP. So it is called Internet Protocol. That is something that is the numbering that we give. It's a 32-bit number that we give to identify anything in a network. So that is required. So now, one of the example could be Apache that you can do. Another thing is Nginx. Nginx is also a kind of software. So if you install this Nginx, it is also a web server. It can also serve the static content. So these are the two examples of a normal static website. So static is nothing but it is something you don't change anything, much of the HTML page remains the same. Dynamic is something where you interact, like if you want to fill some form where you get the fields and all that, that is a kind of dynamic way of interaction with the web. Then you require something more to handle that. Like for example, application server can do it. And also web server also will do it with some plugins, extra plugins you can make it. But majorly these things will be done by application server. Okay, these are some of the examples what goes in behind. Is it fine?
Yes, sir.
Okay. So now coming back to our architecture, now you can see that we need maybe Apache here. Apache should be installed on these machines, and there should be a system admin guy who maintains this, because we are doing this in the normal on-premise. On-premise is nothing but you purchase some space of server somewhere, like you can go to Rackspace or IBM, or you can, like, there are many companies which will sell this on-premise, like where you purchase the servers and you run in some kind of setup. So now you need to have the app servers, like Tomcat can be running on this. And now this load balancer, again, you need to have this HA proxy, what I told you. So nothing but you need to take a Linux operating system, you need to take another machine here, you need to install the HA proxy, which handles the traffic. So this is again, you need to maintain these things. So it's very quite complex if you want to do everything on your own, if you don't have a cloud. And even this relational DB also, you need to have a mission where you run MySQL, and this application server can connect to this, and it can create the tables, and it can store the data, and it can run the queries against that. So this is how the things will be there. Now, instead of remembering the IP, you need to definitely introduce something called DNS, like where DNS is nothing but it's a domain name. So like, again, I'm telling, it can be identified like what you have, the contacts and phone numbers. You can't remember all the phone numbers, right? So what you do in your mobile, so you just save the name, a contact will be saved. So you remember the names. In the same way, you can think DNS is a similar thing. It's a kind of directory which holds name of a domain name and the IP related to that. So now the users normally take fb.com, they connect to this, and first the request goes to the load balancer, and you get a page. That's it. And I'll just want to upload something, and I want to post something. This is how it looks like. Now, if you want to add more things to this, let's try to make the architecture more complex and try to understand how the things will be there. Now, just a relational database also should be scaled, right? So every component should be scalable. Like, let's suppose the load balancer is getting 10 requests per 1 hour, but slowly the fb.com is getting the popularity and many people are started using it, or Instagram or anything. Now you get 1,000 requests per second, 10,000, 1 million requests per second. So the load balancer should be able to take the 1 million requests, and it should be able to send it. So you need to increase the capacity. Like, how do you do in the normal restaurant? Like, you may have 5 to 6 cooks, but if you just have one waiter who is taking all the orders, it's a problem. So now you need to increase the capacity. You will add more waiters here, okay, who will be taking, like, you'll have 4 to 5 people who can take the orders and who can give back to the kitchen. So in the same way, you need to increase the load balancer capacity. You need to scale the load balancer. You need to scale the web servers to handle more requests, app servers. In the same way, you need to scale the DB also. So then normal relational database scaling will be very different. So what I can do is I can segregate the information. I can add something called NoSQL databases. This can be easily scalable. We'll discuss this more when we are discussing about databases in AWS. I'll give you some examples real time, but just understand, NoSQL databases are something you can scale very fastly. Relational databases are something the scaling will be very different, but generally you can segregate the data. Maybe you can store all the details, some details here and some details here. And you also need something called cache to give your queries very fastly. So if I click on a friend, it should definitely go there and show all his friends. So these kind of faster things should be there. So you need to introduce some DB cache. So what this DB cache does is it will take some complex queries, it will store the result with that, and when the same query is executed, it will give you the result instead of going to the DB. So let's suppose if you're searching for people who are in this age group, in this college, in this locality or something, it's a complex query where it needs a lot of fields. So every time if someone is searching for that, like 2 or 3 times, or it going to the DB and giving you the query result will be a bit late. It's a bit, again, it's a costly query. So then you need to save something, that query somewhere, and it gives you. Just imagine like that. Again, we'll go more into the DB cache, like something called elastic cache in the cloud. I will tell you how you do that and how do you create it. In the cloud, it's very easy. Even you'll understand how we can do it. But this is how the architecture looks like. Now, let's make this more complex. Just try to be with me. I'll show how the things are fun when we go into the AWS. Now, let's suppose you're uploading the videos also in the Facebook. So you can't upload, like you can't store every video in the disk, because let's suppose you uploaded a video that goes into this VM and it is stored in this disk. When you make a second request, your request can go here, but your video is here. You may not see the post that you have done in your profile. That's a problem, right? So for that, what we do is generally we have some external storage. All the videos, images, everything will be put in some external storage, and when you scroll, it is connected to some external storage, and it is where it gives you thumbnails first, and when you click on that, it will be connected to the external storage and the video gets popped out and you can just watch it. That is how it will be there. And this external storage should be very, very high. It could be a petabytes, and it should be ever expanding, because you people literally put terabytes of data every second, and it should be a good storage which should be able to handle all these things. Now you need to have some content filters. It's not that you can upload any kind of content in a Facebook or Instagram, right? There will be a filters which will see if it is a violent kind of thing. It should just put it as a blur, or it should completely remove the content. So these kind of content filters should be there. And now there should be a kind of revenue model. So I'll just go very fast with this. So for example, you scroll and there should be ads coming up based on your scrolls and based on your clicks. So it should understand everything about a user. So that is what the main data engineers in the Facebook will be doing. So they'll see what you're scrolling, what you're clicking, and based on your clicks and based on your needs, they'll try to generate the ads for you. That is a main ad revenue stream for that. So for that, again, you need a storage. You need a big data, like artificial intelligence kind of thing, a data warehouse which can generate the things according to the requirement. And the only thing a end user will be saying is, while scrolling, he just gets ads. While looking some stories, he'll just get some ads. This is only what he'll see. But in the back end, it's a whole lot of things that goes how a user should be. Like it will take your analytics and it should run some analytics. This guy is looking for a computer. This guy is looking for any healthy kind of apps. And if you're trying to search for the healthy food and all that, it will see that those kind of ads are targeted to you. So that is how the revenue is generated for the Facebook or Instagram. It may be free for you, but they need to run the business. Now you'll have the people like who access from the mobiles. You'll have the people who access from the web browsers. If you take a video, the people who will access from the web server, web browsers, the video format will be very different, and the people who are looking from the mobile, the video format will be very different. So that kind of video conversion should be there. So when let's suppose I just take my mobile, I upload some video, so that should be converted into a different formats. So this you can also see in YouTube. So when you open the YouTube, you go with the 720p, 480p, right? So in the backend, you may have 3 to 4 different external storages. One storage will be dedicated to 360p, one will be for 720, one will be for a 1080p kind of thing. So it will hit that, it will get you the video which is with that particular resolution. So this kind of conversion should be happen. Okay. And another thing you have is a content delivery network. This is used, for example, let's suppose there are some viral videos, like people generally, someone gives some kind of statement and people try to locate, or some kind of video came up and people try to locate. So that is a kind of viral video. So a user need not come in this path to fetch a video. So you have something called CDNs, so content delivery network. It's a kind of cache where we put the videos. So you can think this in the terms of Netflix and Prime also. So when a Prime releases a new movie, it won't put everything in this storages directly. It will put in the cache, because a new movie is released and a lot of people want to watch it. So it should be very near for you, so that the streaming should be very low, and you should be able to fastly stream it and move the movie forward and back and all that. So that will be put in a kind of cache here. So that is even the Facebook or Instagram, you need this kind of cache to put. Okay, so we made much complex. Maybe some people they may not understand what I'm saying also, but just be with me, because we'll discuss all these concepts in the main course. I'm just trying to give you a kind of architecture, and you can understand how the cloud can easily do this complete complex architecture without much complexity. And finally, you'll have notifications, right? If someone likes your page or your reel or something, you'll get a notification. You can also integrate with the email, like for login and all that. And there is also a message queue where you can chat with the people in the Instagram or Facebook. You need to chat, right? There should be something called a messaging queue, and a different kind of uh, component here for chatting also. And so this is a complete architecture. There will be a monitoring. For example, for example, if this VM goes down, you should be knowing, right? And for example, if the load balancer itself goes down, where your complete traffic is coming, you need to be knowing. So if you want to build this complete thing in a data center, it would be very costly, and you need to install every different component here for different things and all that. Just give me a second. Someone is ringing the bell. Okay. So are you with me? Are you able to understand what I'm saying? Yes or no? Hello? Is it fine,
Hello.
or I'm making bit
Yeah,
complex?
yeah. It's okay. Actually, I have a doubt. Like, if we are accessing anything like fe.com or Instagram, so we are remotely connecting to that IP machine. So it is a kind of machine. So is that right? Or
It's like when you do facebook.com, you are a user. It comes like first it goes to DNS. It checks like, okay, facebook.com is sitting with this IP, and it will just hit that IP, and you'll get like, it will hit the first web server and it gets opened. That's it, as simple as that.
okay? So it is like connecting to some remote machine which is running this FB.
Exactly. Exactly. A remote mission where you're running a web server, it will serve you the content.
Okay. And regarding CDN cache, so is it like if something is in the external storage, streaming it will be a little bit late, so
Little
it
bit
is
easy,
placed in CDN
faster.
or
Yeah.
okay,
So
okay. Thank you.
the CDN, like you can think, if your complete Facebook is in, like let's suppose the Prime is completely in US, okay, the data centers where the Amazon Prime is running in the US. But when you're watching a movie, a Telugu movie or Hindi movie, it should be very nearby, right? They have their small data centers or different locations in nearby, in Hyderabad, in Mumbai, where you have a mission which runs a cache kind of thing, which will stream you the data. So you can just imagine like this. Don't make this
Oh,
complicated. Like, let's say this later.
okay.
Now, what if I want to move this to AWS? That is my whole goal here. So you know there are different components, different things doing different things here. Like maybe it may complex or easy, but you want to migrate this to AWS cloud. So now let's understand what we can replace in the cloud and what it does, so that you know how you can connect the things. Now, firstly, let me just, yeah, now firstly, the network is called a VPC in AWS. It's called virtual private cloud. So if you want to create anything, if you want to create a database, or if you want to create a server or anything, firstly you need to create in a network. That network, we'll call it as a VPC. We'll go into these details more in the course. How do you create a VPC, how do you do that, and all that. But Just for understanding, any private network that you create in a cloud is called a virtual private cloud, VPC, we call it as. Now, these VMs, so just understand this particular page properly. These VMs, right? These are virtual machines where you install a Tomcat, HTTP, Nginx, or anything where you put your HTML pages. These VMs are called EC2. It's called Elastic Compute Cloud in the AWS. So even if you don't remember the names, don't worry. We need to go one by one in this course, understanding all these things. Okay. And the disk that you attach is called EBS. It's called Elastic Block Storage. So we'll call it, like, you can think of hard disk, nothing more than that. But the terms are very different. They'll tell Elastic. Whenever you can increase it, decrease it, they'll name it as Elastic. Just remember that. And this particular symbol is nothing but scale up and scale down. You can add more and more web servers. You can remove them if they are not required. This symbol is called scaling. This is very easily done in AWS. I'll show you. I'll show you all the scaling things, everything during the course. And now coming to these components, a DB and NoSQL DB. In the AWS, you have something called RDS. It's called a Relational Database Service. And for the NoSQL, you have a DynamoDB. Maybe the slide is very big. You missed out the names in the bottom, but this is called RDS. This is called DynamoDB. And now I can change this component, the cache, what I told, which will store the complex queries and which will give you the results. This can be replaced with something called Elastic Cache. Okay, and also observe the load balancer here can be moved to something called Elastic Load Balancer. The name is load balancer, but we call it as Elastic because it can handle 10 requests in 1 second, or it can handle 1 million requests per second. It will do automatically. You need not do anything. In the backend, AWS gives you all that. So you just create some ELB, tell that send the traffic to this EC2 instance or this server, which is serving your content, and it does all the stuff for you. Don't worry about it. And here, the main DNS part, you have something called route 53. So you can think this as a normal directory for now, where you have domain names, IP names. You just enter that, nothing more than that. And all these things, the external storage is something which is like, we call it in the AWS, we call it as S3, simple storage. So this S3 is nothing but it's an unlimited storage you can think of. You can put any images, PDFs, videos, any amount. It expands according to requirement, and you can create any number of, we call it as a bucket, S3 bucket, where you can put all the content. So the naming convention is like this. And you have something called recognition. So it's a kind of content filter. So let's suppose if I just look into this one, so let's suppose I want to add a content filter. So I can just take this service. I can go into the AWS. I want this service. I will integrate with my Facebook or Instagram or whatever app I'm building. So it can do a content moderation. It can look into the phases and search, and it will compare it. It can do the phase analysis. It runs behind this. It runs an AI program which does all the image manipulation, and it can detect the text, and it can detect the labels, everything. Like literally, it can do all the things. Like it can do the streaming video events also on detection. So this is one of the service. So you can see, like, I just replaced this content filter with this service. So that is my intention to show you that here. Okay, so again, let's all the components which are related to external storage are moved to S3 here. And now for the video conversion, you can use something called Lambda function. I'll not go into that. It's a simple function where you can write the code, and the code can execute. You need not require any server or anything to run. So it's a kind of serverless. If someone heard already a term called serverless, it's a serverless. In this course, I'll also teach you about serverless, and I'll show you how you can build the applications using the serverless. It's very easy actually. Now let's move to the other parts. What we can change. This one, like if you see the clickstream analysis and Spark and Hadoop, big data and ETL kind of applications can be moved to Glue, Kinesis, EMR, and this data warehousing is called Redshift. I don't want to go into the details of it. If you don't remember the names, it's absolutely fine. In this course, we'll see about Redshift, and like I'll just S3, but we'll not go into the deeper of big data because this is not a big data course. The name itself just is EMR is a service used for big data. Just remember that. And you have Athena and QuickSight, which can do some kind of analysis, business intelligence. Based on that, you'll get ads and all that. And this is a content delivery network. What we can change it to edge location and CloudFront. So CloudFront is an AWS service, which is exactly used for this content delivery network I told you. So you can think a movie is put in the cloud front, which is you can just stream that very easily, which is newly released. A lot of people are trying to watch the movie. And if you go to these things like mobile notifications, email, queue, dashboard, for all these things, you have the AWS services. Notification service is there, email is there, SQS is there. So in this course, we'll go one by one, all these things. I'll tell you about the cloud front. I'll show you creating a distribution, and I'll show how you can give the source of it and how easily you can create the cloud front distribution. Like one particular class is dedicated to that. And in the SNS, SCS, and SQS, it's kind of notifications, mailing, queuing. One particular course again class is dedicated to these things. So we'll go one by one with all the things. First 1 week we'll deal with EC2, load balancers. Another 1 week will few classes will deal with these things. Few classes will deal with S3. So it will be one by one. Don't worry if you're not able to get like what exactly it does, what functionally what it does. That's not the things for this today. Like it is only to show you what we can do in a cloud which we want to migrate to the cloud. So that is the reason any cloud is so powerful that you can complete your application on the cloud. That is my whole intention of today's class. So now for doing all the loggings, like for example in the FB you can access using your Gmail, or one particular app you can just use FB login and all these things, right? For the authentication you have a service called Cognitive. And for example, for building a REST API itself, like if you're a developer, you want to build a API for your application, AWS gives you something called API Gateway. You can build all the REST APIs, HTTP APIs on this. So in this course, we'll go into Gateway. I'll show you Gateway. I'll show you how do you create an APIs, a very easy one, and how can it invoke the backend services. So how do you do a get method, post method, all these things we can look into this one. And there is security for everything in the cloud. It's not that you just put your information and the things are not secured. You have a huge security. The first kind of service that we discuss is an identity and access management. This is what we start our course with, where you restrict the users in what is their authorized. Like for example, if there is a banking portal, there could be an employee, there could be a customer. If an employee logins to his, like he can look all the customers and he can see the various services. But if a normal backend customer, like who is a bank customer, if he logs into his internet portal, internet banking, he only has his account, right? In the same way, the IAM is one where you can create lot many users, but they are only authorized to do certain things. Developers may be just doing databases and EC2, because I can't give a developer to create a big data cluster. It's very costly. If he doesn't know anything about AWS, if I give him the access to complete services in the AWS, he can just go and create a big data cluster. It's a matter of a click where he gets a complete cluster. And he forgets to turn it off, or he doesn't know what to do, he'll just leave it. He'll go back to his work. But the problem is it will generate money for you. There will be a billing. Like a lot of people, if you don't manage them, they just go and do whatever they want. They can create all the things. So every company will manage these things. For example, these are the developer groups. They should be only able to do EC2 RDS. These are the sysops groups. They can do everything. These are QA people who can only do this one. And this is a developer who does this recognition, these kind of deals, like content filter kind of code he's writing. He should be only be accessible to recognition and EC2 and RTS. So you can do all these kind of things. We'll look into that, how easily we can do just with single clicks. And you have something called encryptions also. So you have a public key encryption, private key encryptions, because data is very much important, right? You put all your data, your client data, your customer data in a public cloud. Encryption is very important. They have their personal information there. They may have the social security numbers. So it's a public cloud. You need to trust AWS because you're putting it. How do you put the data? You encrypt that input. So that is what part of KMS we call it as. Okay, so we'll discuss more of these things during the course. You have we'll go thoroughly through the security, what kind of security things we have in the cloud. These are all again more about security. There is a application firewall, so that it will see that there is no DDoS attacks, because you have, let's suppose you have your e-commerce running in the AWS cloud. There may be DDoS attacks, like Russian or somewhere the people can just attack your website by sending 1 million requests per second. Your complete load balancer and everything can go down if you're not maintaining properly. So you need to have something called WAF, which will see that, okay, from single IP, you are getting 1 million requests. This is a bad thing. So like, and it sees that it is some kind of brute force or DDoS attack. it will not send any traffic to the backend. So that is how it works. And you have a lot of things, a lot of other certificate managers. For example, if you want to do an SSL certificate to secure website, someone is adding the credit card details in your e-commerce website. So the credit card details and everything should be very much secure. You can't just leave it. So you need to have an SSL certificate for your website so that I can enter my credit card information in that, so that all the communication between the server and client. So I said this communication happens, right? This should be encrypted. So if someone in the middleman comes and looks into this packets, we call it as an IP packet. That is how the internet travels, like everything in the internet protocol, IP packets and something. If someone gets that, if he opens it, look the headers and content, he can't see anything because it is encrypted. We have HTTPS. That's the reason when you just look into this, like if I open Amazon.com, so you can see there is a lock here. Okay, so this is the SSL. So it means that the connection is secure, everything is encrypted. They have purchased some certificate, and the certificate is what does the encryption. Okay, so now I can enter my credit card information. You need these kind of things. So AWS provides services to do these things, where you can create certificate and you can add to your website so that the people can enter any of the details that they want. Like, okay. And now finally we come to development and DevOps. This is the cloud formation that I told you yesterday. I told you pick one tool for automating, whether it is Terraform or cloud formation. Like you should be able to create this complete stack in just 1 hour. Okay, for example, if developer tells like I want a complete stack, you just have this completely written in a kind of simple JSON template. You execute that, all the things are created. You create a EC2 instances, you create a databases, you create S3. You can say developer, your stack is ready. If you want, you can deploy version 22.3 and you can check if it is working or not. And if QA comes and he wants another stack, I'm ready. I just have a JSON template, which I wrote all this infrastructure I wrote as a code. I just write a simple JSON things. It's not, if you're not aware of the JSON, don't worry. I'll just show you a few JSON templates. We deal that very regularly. It's a small readable template, a JSON, YAML, all these things. You can easily create the complete infrastructure like a code itself. And now you can also do something called CI/CD for that. Okay, like I told you, Jenkins, right? Even in the AWS, you have similar tools like Jenkins. I'm not sure if you can see the font here. There is something called code build, where you can put the code, code commit, and you have a code build which runs a pipeline. For example, on these EC2 instances, you need to install some JavaScripts and all that. On these app servers, you want to put a WAR files where you're running the Tomcat. So a developer simply writes a code. He will push it to the code repository. There will be a code build job which can take that code, which can create a WAR file, which can deploy it. So these kind of things you can also do in the AWS. And in this course, either way, I will go with the Jenkins or this one. So like it's not like both the things. Both the things are literally same. Yeah, you just write a normal pipeline using a JSON kind of format. Okay. And finally, we'll come to, yeah, this is the final slide I have. This is how you automate all the stuff. So we'll deal with automation also, because you have a stack, you know how you can deploy it onto the cloud, but you need to know these kind of tools to automate the things. So this is what even we discussed yesterday. Don't get confused that the cloud formation is the Terraform that we discussed yesterday. And these are the different components of a Jenkins, like you can just think it of. Okay, anything that you want to discuss, like any doubts here? So this is importance of the cloud, why we need to move the cloud, and what all the different advantages we have the cloud. Like normally in the data center, you can't create these many stacks. Let's suppose a similar stack what we have here, like this is the main stack, right? So if you want this, a QA guy want to have complete these things, maybe not edge locations, maybe not some parts, but much of these particular stack, if QA wants, you need to automate it and you need to just create it within the few hours. Okay, you can just do it. Like if you have a cloud formation, you just run the script, it will create everything for you. So it's like just giving some kind of JSON template, like create this, create this, create this. We'll go into those things also.
So, Sandeep, do we have hands-on on all of these? Like,
Yeah, definitely. Yeah, we'll have hands-on. Definitely, we'll like what all the like maybe I don't teach EMR, Kinesis, Athena kind of thing. All the others will generally cover. And there are more others to cover also, which are not indicated here. But I'm just giving you a overview of AWS services mainly here. Okay, that is my intention here. So we'll have an hands-on, like for example, when I'm telling IAM, let's suppose tomorrow is an IAM that we'll start with. I'll show you how do we create users, how do you create the groups, how do we do in the real time, and you'll have some tasks where you need to do the same.
Okay. And is this on the hands-on on the console only, or command line also?
Both the
And
command lines also. Can everyone be on mute actually? Who is talking? I'm just muting Ramesh. Okay, yeah, you are saying something.
do we have this hands-on for the AWS on just on the console or the command line also? And
Firstly, I'll go with the console. The command line is as similar to the like AWS CLI, does the same thing as what we do in the console. I will show like we have one dedicated class about AWS CLI, how you can create some S3 buckets or EC2 instances. So you can just relate that.
okay. And on the Devops, do we get to build get some hands-on like how to build and
Yeah, I'll show you.
deploy?
I'll show you code pipelines about Tomcat, some real-time examples. I'll show you. I will show how the pipeline syntax will look like. All those things I'll definitely show. That is CI/CD part.
Okay. 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 Thank you.
Thanks. Any other doubts? So even if you're not able to relate to much of the things, don't worry. This course is related to that. The only idea of today's introduction about the cloud is I can just tell these are the services AWS has and these are what it does. That really doesn't make a sense. I thought to show you a real-time architecture and show you how the cloud can help in deploying all this. That's a whole essence of this. So it's not to make the things complex, or it is not make you not understanding certain things. It's to make things relatable and easy for you. Okay, so the first thing I want you guys is creating an AWS account. So what you need to do is you can just firstly do a Google if you don't know anything, and here you can do AWS cloud, just something like this, or AWS cloud console. Okay, this is the first thing. Let me just minimize this. Okay, so you can just go to this one, AWS management console. Okay, here you need to create an account. Okay, the first thing is okay, if I just do a sign in, it will tell if you're a new user, so create a new AWS account. Okay, just click on this. So where you need to enter your details. So maybe you need to give your root email address is nothing but it's a normal email address, Gmail, that you have. You can give an account name also, and just when you verify, you'll get more options where they'll ask you the details, the billing details, where they'll ask you the credit card or debit card information. Just give them. You're not, they won't charge anything for you. And in this course also, I'll show you much what free tier should be having. So AWS has something called free tier. So let's suppose tomorrow we discuss EC2 instance. Okay. So if the first class is while I'm telling some databases, okay, let's go to the database. So I'll tell you to create some RDS. You can see that there is a free tier option for this. 12 months, first 12 months is free, and 750 hours is free. So you can create an RDS with 20 GB storage. So even in this course, I'll go with the free tier itself so that I won't confuse you with going different things. So I'll show you how do you create a database, which is a free tier, which will be which will, if you just leave the database running for complete month also, this 720 hours will be there. It's not like you have few hours left also. So they are giving 750 hours per month. So you can just calculate 30 into 24, and you can see you'll not cross this limit. So this is free for 12 months. So this in this course we'll go again with this. While I'm telling a DynamoDB in NoSQL, so this is always free. You can just go and create something in the DynamoDB, and I'll show you while teaching the course. Now let's suppose if I'm teaching you virtual missions. Okay, again you can see you can create a virtual mission. Okay, that is with a kind of this is an instance type, which I'll tell you later. So you can just create it. You can run the website in that also. The 12 months is completely free for you, and 750 hours you can just leave it. Let's suppose you run two virtual machines. Then this 750 hours will be divided among the two. So you should never be leaving that as running. You can use it and you can just turn it off, and you can see that you are in the 750 hours itself in this particular limit. So first idea is you create an account, and don't worry about, and just create an account and leave it. Don't create anything, because we will be creating as required as the course goes. I'll tell you what to create and how do you do all these things. And you also need to terminate once you have learned that thing, because it's always better to terminate than leave it running. But generally don't worry, like they won't charge anything if you go with the free tier. Even if the free tier is missed and you forgot something, like it will charge around like hundreds or 200 based on that. And if you tell AWS that you accidentally created and you are not sure of it, they'll just waive it off. Even like there are people who there is a guy who just created an AWS account, and his account was hacked because he didn't do a multi-factor authentication. There's a guy from Canada, one of my friend. He has got a bill of around some lakhs per month. But I just spoke to AWS, and we spoke like it got hacked and he doesn't use it or something like that. They waived off all the bill. So, but don't think that every bill can be waived off, and you should never concentrate on that. The only idea here I'm telling you is we'll just go with the AWS free tier terms and policies. And if you miss something, and if there is a billing of 200 or 300 or something, or $10 or $20 also, you can waive it off. But don't think of waiving off things. Just concentrate on only free tier. In this course, we'll just go with the free tier itself. So my idea is first create an account. So tomorrow I'll start with IAM, Identity and Access Management. That will be the first service that we'll deal in this course. And later we'll go to the virtual machines, creating the virtual machines and using the Linux in that, and then go to the Linux internals, basics of Linux, shell scripting, and then go to different services like RDS, S3. That is how the course will be there. And finally, we'll come to CI/CD part, cloud formation, and this gives you a complete like, and I'll give you a real-time example, so you'll be doing along with me. It is not that I'll just show the slides. I will do the real stuff and you do the same thing in practicing.
Okay. And in the build, test, and deploy and all, do we also get to install those tools and use it?
Yeah, you'll install Jenkins along with
Okay.
me, and you'll run some pipelines, and you'll see how do you run the pipelines and look the syntax and all that.
Okay. Thank you.
Is it fine? Are we good?
Yes.
Yeah, sure. Okay, we'll meet you tomorrow again, the same time. Have a nice day.
And
Good
also,
evening.
Sandeep, for closing,
Yeah.
where do we get this recording to
Yeah,
distribute?
this recording, Career IT guys will give you, and even if you want the slides also, they will give you the ones that I showed you.
Okay.
Okay, thank you. Bye.
Bye.
Thank you.